Hey guys, today we're going to be talking about special parallelograms. And you're going to need to know about rectangles and the properties that apply there, and you're going to have to know about rhombuses. Okay, so let's go ahead and start with the rectangles. So go ahead and write something on the side here. Okay, so the first one, if a quadrilateral is a rectangle, then it is a parallelogram. Okay, so if a quadrilateral is a rectangle, then it is a parallelogram. If a quadrilateral is a rectangle, then it is a parallelogram. So if you have a picture of a rectangle, you know a rectangle have opposite sides that are congruent, and you know that each angle is 90 degrees. So if you have a quadrilateral that is a rectangle, then this would be a parallelogram. Okay, so that's the first thing you need to know. Secondly, if a parallelogram is a rectangle, then its diagonals are congruent. So if you have a rectangle, then you know that its diagonals are going to be congruent. So diagonals are congruent. Okay, so those are the two things you need to know about rectangles. Okay, so let's look at our first question here. It says a woodworker constructs a rectangular picture frame so that JK is 50 and JL is 86. Okay, so we know that JK is 50, and we know that JL is 86. And we want to find, there we go, 86. And we want to go ahead and find HM. Okay, so since we know that the diagonal is 86, and we know that diagonals are congruent, well, we know that HM, this guy, is going to be half of the length of that diagonal. Okay, so if we take 86, the length of our diagonal, and divide it by 2, that gives us an HM value of 43. Okay? All right, let's try another one real quick. It says the rectangular gate has diagonal braces. We want to find HJ and we want to find HK. Okay, so let's find HJ. Well, we know in a rectangle that opposite sides are congruent. So since GK is 48, we know that HJ is also 48. Okay, so our HJ is 48. Okay, let's find HK. Now we're going to have to figure out what our diagonal is. So since we know that LJ is 30.8, we know that LG would have to be twice that amount. So twice that amount, 30.8 times 2 would give us 61.6. And now since we know that diagonals are congruent, we also know that HK would be 61.6. Okay, so we know that HK is 61.6. Okay, so those are your properties on rectangles. Now we're wanting to take a look at rhombuses. So once again, go ahead and carve out some space to write a few theorems down. Okay, the first theorem is that if a parallelogram is a rhombus, then its diagonals are perpendicular. So if you have a rhombus, then you know that the diagonals are perpendicular. So the diagonals are perpendicular. And remember, perpendicular just means that they make a right angle. So all these guys in here would be right angles. Okay, so diagonals of a rhombus are perpendicular. Okay, the next one that I want you to write down is that in a rhombus, each diagonal bisects each angle of the rhombus. So if you have a rhombus, your diagonals would bisect those angles that they come from. So if we had angle 1 and 2, for example, those would be congruent because they're bisected. 3 and 4 would be congruent to each other. 5 and 6 would be congruent to each other, and 7 and 8. Okay, so those diagonals bisect each of those angles. Okay, so write down that diagonals bisect. Okay, so those are the two things that you need to know about rhombuses. Okay, so let's go ahead and take a look at this. All right, TVWX is a rhombus, and we want to know, find TV. Well, we know that in a rhombus, each of our sides is congruent. So basically, it's just kind of a tilted square. Okay, so we know that all these guys are congruent. So we need to take two sides and set them equal to each other. Okay, so we've been given WV and we've been given XT. So let's set 3B plus 4. Let's set that all equal to 13B minus 9. Okay, let's go ahead and solve this thing. Okay, this is a variable with both sides equation, so I'm going to undo addition with subtraction. Okay, those b's cancel out, and that would give me 4 equals 10b minus 9. Okay, so then we can go ahead and add 9 on both sides. That would give me 13 equals 10b, and then divide each side by 10. Okay, so if you divide each side by 10, your b would end up equaling 1.3. Okay, so since we want to find TV, we got to go ahead and plug back in. Now, we aren't given a value for TV to plug into, but we know that all of the sides are congruent, so we could either plug in here or here, it doesn't matter. And I'm going to plug into 3b plus 4. Okay, so we have 3b plus 4, and we can plug that in with our b. So this is going to be substituted in. So we have 3 times 1.3 plus 4. And if we multiply that together and add 4, you would end up getting 7.9 for TV or any of the segments in that particular rhombus. Okay, let's try one of the angles. Let's find a measure angle VZT. Okay, so we're wanting to find this angle. Okay, so we know that VZT is 14A plus 20. And what do we know about each of the angles on the diagonals that are, or the angles that are made up by diagonals of a rhombus? Well, we know that rhombus's diagonals are perpendicular. So we're going to set that equal to 90. So let's take 14A plus 20, which was VZT, and we're going to set that equal to 90. So let's undo addition with subtraction. That gives us 14a equals 70. And if we divide that out, divide by 14 on both sides, our a ends up being 5. Okay, so since VZT was 14a plus 20, we can simply plug in our 5 back into our equation here. So we have 14a, so let's plug that in. So we would have 14 times 5 plus 20, and that would go ahead and give you your answer there. All right, this one I would like to try by yourself and see if you can go ahead and find that one. I want you to find angle VTZ, and remember that your diagonals bisect each angle. All right, we got one more example here to look at. Okay, so CDFG is a rhombus, and we want to find CD. Remember, your rhombus, all sides are congruent, so we can simply set any of those side lengths equal to each other. So since CG is 5A, we can set that equal to GF, which is 3A plus 17. Okay, so let's go ahead and solve. We got subtract 3A on both sides. That gives us 2A equals 17. And of course, if we divided each side by 2, that would give us A equals 8.5. So if we wanted to find CD, we just got to plug 8.5 into any of our other segment lengths. So I'm going to use 5A. So we got 5A, but if we substitute in our 8.5, what would that give us? 42.5? And since all side lengths are congruent, your CD side length would also be 42.5. Okay, let's try one more real quick. It says, find measure angle GCH if measure angle GCD equals B plus 3 and measure angle CDF equals 6B minus 40. Okay, so let's draw a picture of those two angles. Okay, so measure GCD is this guy, and CDF would be this guy. Okay, so you have consecutive angles. Well, what do we know about consecutive angles of a quadrilateral? Well, we always know they add up to 180 degrees. So I can take this and add them up and set them equal to 180. So we have B plus 3 plus 6B minus 40, and that always equals 180. Okay, so let's solve this. Let's combine like terms. So we would have our B's that we need to combine. This is supposed to be a B, wow. Okay, so we have B plus 6B, which is 7B. So we have 7 B's, and if we add up 3 and negative 40, that would give us a negative 37. So 7B minus 37, and that is all going to equal 180. Okay, so if we add 37 to both sides, that gives us 7B equals, what is that, 217? And then lastly, if we undo multiplication with division, our B would equal 31 degrees. Okay, so then of course you could go ahead and plug in, and that would give you your solution. So we have GCD is twice the amount as GCH. So let's plug in 31 into GCD. So you have B plus 3, so 31 plus 3 equals 34 degrees. And that would be our GCD, this whole amount. Okay, so this whole angle. But we know that diagonals bisect that. So GCH, what we're trying to find, would be half the amount of this 34 degrees. So divide that by 2, and we would have 17 degrees for our solution.